My name is Jeff Geerling, and you might know me around the web as Geerling Guy. This is a presentation called Ansible 101, and it's a brief, quick introduction to Ansible. The presentation is made possible by my book, Ansible for DevOps, Server and Configuration Management for Humans. You can buy the book right now, and it's just about finished, from leanpub.com, and you can also find out more at ansible4devops.com. Ansible is what I like to call configuration management for humans. It's really simple to use, it's really simple to get started with, and it does everything you need to do to automate your infrastructure. Ansible uses SSH for its transport, so you don't have to install extra software on your servers, you don't have to open up extra ports or have extra daemons running on your servers. SSH is secure, fast, and simple, just like Ansible, and that's why Ansible uses it. You probably already have it set up for all your servers. Ansible also has 300 plus built-in modules, meaning you can do anything from managing to users, to installing software, to managing configuration files, and even doing things like notifications and managing provisioning of new servers using Ansible directly without having to install any extra tools. The best thing about Ansible is that you don't need any extra configuration management, any manual process, or any extra tools to manage your configuration management system. Ansible does everything out of the box, and you don't have to install anything extra on your servers just to use it. It's really easy to get started using Ansible. I usually use pip, which installs the same way on all platforms, and lets you get the latest versions of Ansible right as they're released. But you can also install Ansible using your favorite package manager on the Mac or on CentOS or Ubuntu, whatever kind of platform that you're using. And there's four main parts to Ansible. We're going to go through inventory, ad hoc commands, playbooks, and roles. And to do that, we're going to introduce Ansible using the Dramble. The reason I call it the Dramble is because it's actually a cluster of Raspberry Pi 2 computers running Drupal 8, and I use this for testing and infrastructure deployment and things like that. It's a lot more fun to use these live bare metal servers than it is to use VMs on my laptop, even if they're a little bit slower. You can find out a lot more information about the Dramble at the link at the bottom of this video or in the description below. So first we're going to go through inventory. Inventory is just a basic way to tell Ansible, here are my servers. And inventories use INI syntax. You can also use other formats and even use scripts to build your inventory, but we're just going to cover the basics. And Ansible will look for an inventory file in etc/ansible/hosts. You can also override this and use your own custom file using the -I command in the command line. The format for an inventory file is pretty simple. You just have a group name in brackets and then the hosts in that group. And these hosts can be DNS, it can also be IP addresses, whatever you prefer. As long as your computer can see the hosts, Ansible will put them in the group and connect to them. So I'm going to give a quick demonstration of the inventory file that I'm using with the Dramble. So I'm going to switch over to my terminal and say cat etc ansible hosts. And this is the file. So first at the top, I have a load balancer that's going to take incoming requests and send them to the web servers. And there's only one, so I have a group name and then the hosts. And then again, I have web servers, that's the group name, and then the hosts that are in that group. And again, these can be domain names or these can be IP addresses. As long as Ansible can reach, as long as your computer can reach them, Ansible can communicate with them. Then I have a group called database with my database server, which is the bottom server in the rack. And then I also have another group called Dramble that I can define that has these other groups that I defined earlier inside of it as children. And that way I can also say, use this variable for all these different servers and all these groups. So Ansible lets you do a lot of flexible things like defining variables, in this case the Ansible SSH user to use, for all of the servers inside the Dramble group, which includes the balancer, the web servers, and the database. Your inventory might be a lot simpler or a lot more complex. It really doesn't matter as long as it's describing your servers to Ansible. So let's switch back over to the presentation, and I'll show you an ad hoc command. Ad hoc commands are basic ways of running commands or Ansible modules on your hosts, on your servers. And the format's pretty simple. You have the Ansible command, and then you pass it a group name, and then you pass it a module, and then you pass some arguments for that module. By default, Ansible the command will use the command module to run a given command on your servers. So in the basic use case, you can say Ansible group -a and then the command to run, and it'll run that command on your servers. So in my case, I usually run one command in particular just to make sure that I can connect to my servers, and I'll run that now. We're going to demonstrate some ad hoc commands, and I'll first demonstrate that using Ansible's veritable ping module. So if I say Ansible all, or I can say Dramble to connect to all the different servers, -m ping, that's telling Ansible to run the ping module on all the servers. Ansible will connect to all the servers and ping them and see if they return a pong. And it looks like they all did, so that's wonderful. Ansible also helpfully tells us that there was no change on the server as a result of this. All that happened was the server ponged. If we did something like change the user account or installed new software, Ansible would say changed equals true. But in this case, there were no changes. And that first ping took a little time because it was the first time Ansible was connecting, but now that Ansible has a connection to the servers, future connections are much quicker. You can see we're communicating with all the servers very quickly. So another thing that I have with this Dramble cluster is an RGB LED on the front of each Raspberry Pi. Right now they're all green, but I can actually change the colors to show you how Ansible is connecting. So in the first case, I will change all the web servers to blue. I have a script on the server called RGB that does this for me, and I can say Ansible web servers, and that's the group name, -a RGB blue. And then I have to use sudo, so it's -s, or you can say --sudo. And it should turn the LEDs on the front of all the web servers blue. And we can change them back to green if I say Ansible all -a RGB green -s. And now all the LEDs are back to green. Now you'll notice that Ansible is running this command very quickly on all the servers at once. We can actually control Ansible's connection behavior. We can tell Ansible that instead of connecting to all at once as quickly as possible, to connect to one at a time using forks. There's a few different ways that Ansible can connect to your servers, and this is the simplest when you're running ad hoc commands. You can override this behavior by saying --forks equals 1 to connect to one at a time. So instead of Ansible splitting off and trying to connect to all of them at once, it'll connect to one at a time. So if we do that, it should start at the top and change the LED on each Pi individually. And to show you again, let's switch them back to green. And there it goes. And you can do 2 forks at a time. If you're going to change 2 servers at a time, and Ansible is very quick to connect to these servers. And you can even say 6 forks, and that will just basically run the command on all the servers as quickly as possible. By default, Ansible is set to have 5 forks, but you can override that default in your Ansible configuration file. Using the inventory that we set up, we can also just target the database server. Ansible database RGB red, and we can switch its LED to red. Of course, for some of the OCD people watching this, you might not be very happy with having one LED that's different, so we'll switch it back to green for you. And I was thinking to myself that since I had this cluster with 6 RGB LEDs on it, and since they're pretty bright, if I ever need an extra flashlight, I set up a command that I can set any color that I want. And then if I need to, I can carry the cluster of Raspberry Pis around my house and see what I need to see. Of course, that would also require that I bring my network and my power with me, but I have long extension cords, so I can do that. Let's set all the Pis back to green. And, whoops, haha, all. And I can show you a couple commands that might be a little bit more helpful in real-world usage. So if I want to see quickly how much memory my servers are using, I can say free-m, -a for an argument, and it'll tell me how much memory is in use on all my servers. Ansible also has a cool module called the setup module. And the setup module will take everything that Ansible knows about your server and output it so that you can get information about your servers, like how much memory is available, what kind of networking it's using, what kind of operating system it's on. Pretty much anything that you can figure out about a server will be in this listing if you use the setup module. It's a quick way to get information about your servers that you can react to when you're building playbooks and doing things with your servers. So that's the setup module. And you can also do things like pipe output from one command into another. If you're going to do that, you have to actually specify the shell module. So if I say Ansible-all-m-m shell, and then you can do things like pipe the command of ifconfig over to grep, and then you can get the IP addresses on your servers, that kind of thing. If you don't use the shell module, then you'll get an error, because by default Ansible uses the command module, and the command module can't handle pipes and redirection correctly. So make sure you use the shell module if you need to do that. Ad hoc commands are also helpful if you need to quickly restart services or shut down servers, that kind of thing. So in this case, if our web servers are running Nginx, then I can run the service module, which is Ansible's module for controlling, starting, and stopping services. And I can say name equals Nginx of the service to handle, state equals restarted, -s. And then in this case, I want to make sure that it doesn't restart on all 4 servers at once, since I want my load balancer to be able to get some live traffic through. So I'm going to say forks equals 2, so it does it on the top 2 servers and then the bottom 2 servers. And so Ansible will do that, does it on the first 2 and then the second 2, and tells me that it changed the state of the server because it restarted the service. So that's helpful. So let's get back to playbooks, because it's all great and good to be able to run these commands on servers, but it'd be even better if you don't have to run them at all because you have playbooks to do it for you. So the problem that a lot of people have is they have these snowflake servers, or some people refer to them as pet servers, where you log into the individual servers and do things on them, or even if you're managing them in groups, you have to log into them and do things to them. And you might not have everything documented, and you might not have every configuration file codified so that you can reproduce the server from scratch in a heartbeat if you need to. And so what we want to move to is having all of your infrastructure in code. And then eventually you also want to move to an idea of having immutable infrastructure, where you bring up new servers and then replace your old servers with the new servers instead of having to update a server. You can do that kind of stuff once you have everything codified in a playbook. And a playbook is a simple YAML file. It's very easy to write and read, and you can run playbooks with the Ansible playbook command. So I'm going to show you a quick demo of a playbook. And in this case, the playbook will be running. We'll be building a web server with Nginx on it. And here's the playbook. So for a YAML file, you start off by using 3 dashes. That tells the YAML interpreter that the rest of this document is going to be YAML syntax. And then you give Ansible a list. And this list is just a list of plays. In this case, we're just going to do one play. And that play is going to run on the web servers. So we tell it what hosts it's going to run on, in this case the web servers. We also tell Ansible that we want to use sudo, because we're going to need to use sudo to run certain commands like installing software and managing users. And then we tell Ansible, much like the forks setting on ad hoc commands, we tell Ansible to run this in serial on sets of 2 servers at a time. And what this will do is it'll run this whole playbook on 2 servers, and then it will run it on the next 2 servers if those first 2 are successful, that kind of thing, so that you can do 0 downtime deployments and rolling deployments, that kind of stuff. The rest of this playbook defines some of the information that Ansible uses to run the playbook. So first we have a section called vars that defines any variables that we're going to use in the playbook. In this case, we just have one variable. And a lot of times you would want to define this variable in your inventory, or you might define it in an external variables file. In this case, we're just putting it inline here. And this variable will be used later in the Nginx template. Then there's 2 sections, pre-tasks here and post-tasks after the main tasks section. And these sections are for things like putting your server in and out of the load balancer, notifying your team when a deployment's beginning and ending, those kind of things that you can do. In this case, we're going to use the RGB LEDs on the Pi to indicate when the server is being deployed to, so that we can see when Ansible is communicating with it. And then there's a set of tasks, and these 3 tasks will first make sure that the My App user account's present, then it will make sure that Nginx is installed, and then it will make sure that there's a configuration file on the server for that server, for Nginx. And then at the end, we have this section called handlers, and these are the same thing as tasks, but these can be called from tasks when there's a change. So in this case, we see that there's a handler called reload Nginx. And what will happen is if this task up here, which says notify reload Nginx, if this task results in a change, it will call this handler at the end of the playbook and reload Nginx. It'll use the service module to do that. In each of these tasks, so the pre-tasks here, there's 1 of those, and then the tasks, there's 3 of those, and post-tasks, there's 1 of those, and even the handler is just a task. Each one has a few components. First is the name, and this is just to document what the task is doing. When Ansible's running, it will take this text and put it into your output in the terminal so you can see what's going on. Then you give it the module name that you're going to use. In this case, we're using the command module to run a command on the server. And then you give the module the arguments for that module. In this case, there's a command. Down here for user, there's a bunch of key value pairs to tell the user module what to do. And then you can also give other options. Like in this case, we're saying changed when. This never results in an actual change in the configuration, just in the LED status on the Raspberry Pi. And then down here, there's also notify to notify that handler when there's a change. And then we have the main part of our playbook, which does all the grunt work. So there's first, we use the user module to make sure that the My App user is present on the server with this shell and in this group. And then we have a task that uses apt, one of Ansible's package managing modules, to make sure that the Nginx package is installed on the server. And then we have a template module that will take a template that's in this folder and this file, which is right here, and it will copy that template after it replaces all the variables inside that template to this destination using this file mode. Now here's this template file. It's in Jinja 2 syntax. And if you look, it's pretty simple. A variable is just printed with 2 handlebars, 2 curly brackets. And that's this variable that we defined earlier, Nginx listen port. And that you can see is right here. And when Ansible copies that template to the server, it will replace that variable and set the file mode. And then if that results in a change, so if we're running this for the first time, it'll actually restart Nginx after that happens. So let's take this playbook and let's run it on our web server. So let's make sure we're in the right directory and then run Ansible playbook.yaml. And if I run it on the servers, it'll connect to them. It'll first do the first 2, and then it'll do the second 2. You can see it starts on the top 2 web servers. It runs all the tasks on them. Then it'll switch to the second 2 servers and run all the tasks on them. And the cool thing about using Ansible modules for all this, we could have run a bunch of commands like a shell script, or we could even run a shell script to do all this. But the cool thing about using these modules is that they ensure that you can do idempotent deployments. So the first time we run it, it results in a bunch of changes, and Ansible tells us there were 3 changes on each server. The second time we run it, though, Ansible is intelligent enough to know that it doesn't need to change these things, and it doesn't need to restart Nginx. So if we run it again, Ansible will still go through the full process, but it'll show us at the end that nothing resulted in a change. And so you can run this playbook as many times as you want. You can even have it running as a periodic job through a continuous integration tool, and it'll just tell you that your infrastructure is in the correct state, as long as you're using Ansible's modules and doing everything with an eye towards idempotence. So that's our playbook, and that's how a template works and how some of the basic tasks work. But one thing that I noticed was that a lot of our configuration was for Nginx, and it'd be nice if we could compartmentalize that and put it in its own place so that we can make our playbook a little simpler to read. So roles are Ansible's answer for that. You can encapsulate your configuration in small reusable chunks, and there are actually more than 4,000 roles on Ansible Galaxy that can help you configure pretty much any application that's out there. You can build your own roles, or you can use these contributed roles. And if you want to build your own role, like in this case, we might want one for Nginx, you run the command Ansible Galaxy init, and then the role name. So let me switch over to here, and you can see in my roles folder there's no roles. Typically you'll install roles in a roles directory with your playbook. So if I cd into the roles directory, and then I say Ansible, Galaxy, init, Nginx, Ansible Galaxy will create that role for me. And if I switch back over here, you'll see that there's now an Nginx directory. And Galaxy creates all these different folders for me, but there's only a few that I'm typically interested in when I'm building out a new role. For example, there's the defaults and vars directory. Defaults is where you want to put most of your variables. The vars directory is good for variables that your role needs, but they might not want to be overridden by other playbooks. Defaults are for variables that you might override in your playbooks. It makes it a lot easier if you put them in here. So we're going to take this Nginx listen port and put it into our defaults file and save that. And now I can take this section out of my playbook. And then we have a couple tasks that make sure Nginx is installed and configured. So I'm going to copy those tasks out, and I'm going to put them into the tasks file for my role. Save that. And then it looks like there's one handler, reload Nginx, and I can take that handler out and put it in the handlers file. Save that. And then the last thing that I need to do to make sure that my role works correctly, I can delete that section out of my playbook, is go to the meta folder and look in this file. This file, by default, has all this Galaxy information. If you want to contribute a role back to Ansible Galaxy, you can fill this in, but it's not needed if you're using a private role or a one-off role for something. But you do need to define dependencies. If your role is doing something like installing Apache Solr, you might require Java. So you might have a dependency of a Java role that has to run before your Solr role. In this case, we're just installing and configuring Nginx, so we have no dependencies. So we'll just set an empty array here. And now that we have this role filled out, I still need to copy this template file into it. So let me grab this file and put it into the roles templates directory. And then one more thing to make sure is, that my task doesn't have the templates folder, because Ansible knows when you're using a template in a role, it'll pull it right out of the templates directory. And to call that role from here in my main playbook now, all I have to do is add a new section to the playbook, roles, and then give it a list of roles. So in this case, Nginx. And if I run the playbook again, then it will use that role. Whoops, I'm in the wrong directory. If I run that playbook again, it'll use that role instead of the inline tasks to do the Nginx setup. So this will take a second. But now it also prefixes all the tasks that are in that role with the role's name and a pipe, so you can see what role tasks are coming from. It's very helpful. And of course, there are no changes because we didn't do anything that resulted in a change. And the cool thing about roles is you can actually make an entire server setup using just a few roles. So for a lot of my servers, I have this kind of playbook with a security role, and that might set up your firewall and some security settings, an accounts role that sets up different accounts on the server, and in this case, it's a web server, so it's running Nginx, and it would do some deployment steps, like maybe pull down a Git repository and put some files in place for my app. So this could literally be your entire playbook for a server, and you can use a few different roles to compartmentalize the configuration for these different things. So roles are very powerful and simple ways to do that. So there's a whole lot more to Ansible, and I hope that this presentation showed you just how easy it is to get started. We're already managing this cluster of Raspberry Pis, and we're well on our way to getting our application running on them in just a few minutes. And there's a whole lot more to Ansible that I can't cover in this presentation, but I do cover it in my book, and there's tons of information about it on Ansible's documentation. But things like using Ansible Tower to automate the automation steps that you do and make it team-based so you can have different people control different environments. Ansible also has deep Jenkins integration and other CI tools. You can do continuous deployments very easily. Ansible has Docker integration for building and deploying images. It has integration with all the major cloud providers and many smaller ones as well, and it's easy enough to write your own configuration. so that you can provision servers and control your infrastructure that way. Ansible also has tons of notifications modules. You can do rolling updates and zero downtime deployments. Ansible has a heck of a lot of stuff built into it that I can't cover in this presentation. But I would recommend that you go and read Ansible's documentation and also see some of my repositories on GitHub, like my Ansible Vagrant Examples repository, and the Dramble repository has a lot of Ansible playbooks in it, and examples of how you can build different kinds of servers. And again, I have a book called Ansible for DevOps, and that book is what's basically covering the first 3 chapters in this presentation. So I hope that this has inspired you to automate your life and automate your infrastructure, and hopefully maybe even buy my book. Thank you.